Okay, so you need to use implicit differentiation. So what are you going to get? 2y, y prime plus 3 times xy plus 1 to the what power? 2 times what? You have to use the chain rule on this, right? Times what? What do you have to use on xy? Product rule. The derivative of the first times the second plus the first times the, and what is that going to equal? 0. So you're looking for y prime at 2, negative 1. Do you have to isolate y prime at this point? No. What can you just plug in for x and y? Plug in the values, right. So you get 2 times negative 1 times y prime plus 3 times xy is what? Negative 2 plus 1 squared times y. Oh, sorry. What is it? Negative 1 plus. What did I do there? Oh, negative. Thank you. Thank you. I missed it. Yeah. Plus 2y prime equals. So now you just have to clean it up, right? Negative 2y plus, what is that? Negative 1 squared. So it's going to be 3 times. It's blinking. Oh, no, no, not this syndrome again. Not this. Negative 1 plus what? Plus 2y prime equals 0. It's going to blink back and look awful, but that's just how it is. Okay. Plus what? Negative 2y prime. Yeah, it blinked. Yay, exciting. That's going to be 3 turned into 1, negative 1 squared, right? 2y prime minus 1 equals 0. So negative 2y prime plus 3 times 2y prime minus 1 is equal to 0. I wonder what percentage of people do this problem on the test and then just mess up in the algebra somewhere, like I've repeatedly been doing with my blinky screen. 6y prime minus 3 is equal to 0. Yeah, blinky screen, yeah. That's a good point. Equals 3, so what does y prime equal? Is that one of the answers? Yeah. Is that the one that is the answer? The graph of the function represented by the Maclaurin series blah, 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 intersects the graph of y equals x cubed at that. So what do you have to figure out? What's the first thing you have to figure out? What is that? What is that? But what series is it? What is that? Okay, first of all, let's just write down what we know. What do we know? We know e to the x is equal to what? 1 plus x plus x squared over 2 factorial plus 3 factorial plus 4 factorial, right? Let's just see, what else do we know? We know that sine of x is an odd function. So which one is that going to be? 1 minus. Which one is it? What do I do? Do I start with x? Or which one do I start with? I got it. 1 factorial minus what? 3 factorial plus x to the 5 factorial, right? Like that? Oh, it's minus, yeah. It keeps going. Yeah, sorry, I was doing the arbitrary. And then what's cosine of x? 1 minus cosine squared over 2 factorial plus x to the 4th over. Okay, so we know that. That should be. Oh, I keep on doing that, don't I? Here, I really don't like writing that. Minus. I guess you don't really have that so far in my head. Okay, so then we think to ourselves, can we match that in any way right there?
Could that be cosine minus sine?
Well, what do we notice? First of all, we notice it goes x to the first, then x squared, then x cubed. Is it just cosine? No. Is it just sine?
No.
It looks like it's 1 minus what? Oh, excuse me. It looks like it's.
Cosine x minus sine x.
Yeah, so if you did cosine x minus sine x, what are you going to end up with? 1 minus x, right? Plus x squared over 2 factorial minus.
Wait. No, never mind.
What? It doesn't work out? Well, hold on. I think I did that wrong. 1 minus x minus x squared over 2 factorial, right? Plus x cubed over 3 factorial minus. Oh, I got to go back to plus, yeah. What's wrong? Are the signs wrong? We have the minus x is right, but then minus plus minus plus. It should be alternating, right? So the first thing I want to ask you is, does that work?
Yeah,
Yeah, it does, because you get minus x and then you get minus x cubed over. Good job, Thomas. Right. So that was very well done. Good job. That's a good substitution. So all you're doing now is this a calculator section? It better be, right? Or like to 3 decimal places, find out where they intersect. You know, it's like I don't want to.
E to the negative x there.
Thank you. Whole point of it was e to the negative x. Good job. That was a really good save. Very cool. But the idea is, can you build? You need to have it in your in your head. You can build a whole lot of things out of what you know already. So what do we got here? We have limit, integral on top. But what do we know? What's the limit as x goes to 1 of the integral of 1 to x, a badly written x, 1 to x of e to the t squared dt? What is that going to? 0. And the bottom is also going to 0, so we have 0 over 0. I know. So what applies? Yay. So what can we do? L'Hopital's rule is going to apply. When you take the derivative of the top, what do you end up with? E to the x squared over 2x. And this is the limit as x goes to what? 1. So what's this going to be? E to the first over 2. Done. Do you remember what you have to do? It's going to be from 0 to 1. Is it from 0 to 1? It is going to be from 0 to 1. And it's going to be the square root of something dt. But what goes on the inside here? Do you remember? dy dt, yep. Squared plus dx dt squared. Right. So dy dt is going to be what? What's dy dt going to be? 2t, right? Oh, it cancels with the 1/2. I'm awesome at doing these. Excellent. It's going to be t squared plus what? T squared squared? Like that? T squared plus t to the 4th dt. Is that one of them? I think that's one of them, isn't it? And is c the answer? I think so. Do you remember what the equation was for finding that area? Do you remember what it was? No. Oh, okay, good. At least it was 1/2. It was 1/2 what? Like alpha to beta, right? Of what? What did we call it?
It was
1/2 r squared. Do you remember?
D theta.
D theta, right?
D theta.
1/2 r squared d theta, right? And it was the r. So in this case, it's going to come out to be 1/2. Let's just do the inside first. What's our outer one going to be? 4 sine theta. And what's our inner radius going to be? 2. So we're squaring this d theta. First of all, do any of those match that already? A few of them do.
No.
Really?
No.
This matches it.
4 sine theta.
4 sine theta minus 2.
Minus 2 squared.
Everything is squared.
The whole thing is squared.
The whole thing is squared?
The whole thing is squared. The whole thing is squared.
First 3 match.
No, you need to separate them.
So it's not this. What is it?
It's
Really close to this. It's
4
this
sine
one squared
theta
minus 2 squared. Very good. Very good. I don't want. I'll go away. Okay. You're,
4?
I don't go away. Look, I love it when it gives you like 3 messages and you can't close them until you do this. Nice. There, you win. Okay. You're absolutely right. You have to subtract them because if you don't, you're basically taking that distance and tacking it to the origin, which will make it a lot smaller than it actually is. So then, that's a very good catch right there. Good catch. So that automatically brings it to these right here. So what's the only other thing you have to figure out?
The limits.
The limits, right? The area of the region inside 1. So how do you figure that out?
Where they intersect.
Excellent, where they intersect. So it's going to be 4 sine theta is equal to what?
2. Therefore,
Sine theta is equal to 1/2. When is sine equal to 1/2? What is sine inverse of 1/2? When?
Pi over 6. Pi over 6.
It's pi over 6 and 5 pi over 6? Yeah, I mean, the other thing you realize, it's not 0 and it's not pi.
Yeah.
So which one does it have to be? D.
D.
That was a really good catch. That was McFall. That was a very good catch.
419.
Yep. Did we get it wrong?
Then oh wait, it's BC. Never mind.
I did that too. Okay, so when x equals 8,
That's lots of that.
the rate at which the cube root of x is increasing is 1 over k times the rate at which x is increasing. So what do we need to set up? Say it again.
It would be 1 over the derivative.
The rate at which that is increasing is 1 over k times the rate at which.
X is increasing.
So tell me what I should set up for an equality.
Okay.
That's going to be what? 1/3 x to the
4 negative.
negative 2/3. So the rate is increasing is equal to 1 over k times the rate at which times what? times 1.
Yeah.
And it's when you plug 8 into there.
Yeah.
So we do 1/3 times 8 to the negative 2/3 is equal to 1 over k. This is a great question. Really like this one. What's 2 to the negative 4? So it's 1/3 times
2 to the negative 4. What?
2 to the negative 2.
Yes, you said 2 to the negative 4.
I was saying the answer and it all at once. So what's k equal to?
12.
12. Cool. Population of a satisfies a logistic differential equation, so it's one of those S-curve kind of things. Nice. Where the initial population P of 0 is 3,000, and T is the time in years. What is the limit as P goes to infinity here? So basically, it's asking for what's the term they're looking for? It's a population. As time goes on, what's the carrying capacity? Exactly, the carrying capacity. So how do you figure out what the carrying capacity? Yeah, I know. I understand what you mean. It's like basically, so you don't have to do the integration by hand.
Yeah.
You need to remember what it is. I don't think it could hurt to know it, but I can't be. I don't know. I can't come up with an example.
Over AE to the KT.
Yes, it definitely is. But what do you know? So you know that dp dt is equal to 2p times 1 minus p over 10,000 right there. So this right here, because it's in k times p times, it's k times p times 1 minus p over the carrying capacity.
Yeah.
And therefore, this is your carrying capacity right there.
Different K's, right?
Oh, little k. Sorry, little. Yeah, I'm sorry. Excuse me. Right,
No,
exactly.
10,000 has 4 zeros, not just 3.
I can't write this. I'm doing it, and I'm like making sense in my head, but then it's not translating well. Already, I'll like highlight this or something, right? So what is that? That's the carrying capacity, right there. Cool. Do you understand what it's saying? So could you draw a picture? Literally draw a picture of what this is?
Yeah.
It's saying this. So if you draw this, let me get this in here. If you draw it, it's a quadratic. Is it facing up or down?
It's facing up.
It's facing up, right? You can factor it too, can't you? If you really wanted to. X minus 3, x plus 1, right?
Yeah.
Like this. So x minus 3, x plus 1. It's concave up, so it's going to look...
the other way around.
Oh, did I flip the signs?
Yes.
So
Say
it's
the
x.
X is going this way.
Oh, it's positive 3, negative 1.
Positive 3, negative 1. So it's right there and there. Are we okay with this?
Yes, it's 4 roots.
There you go. It's crossing at 3 and negative 1. And at x equals 2, you're using this tangent line right here. See that right there? So then it's saying, which of the following is the greatest value of x for which the error resulting from this tangent line is approximation is less than 0.5? Well, what's the equation for that line? Well, what's y prime going to be equal to? 2x minus 2. So what's y prime evaluated at 2? 2. So what's the equation of that line? Y minus...
2.
Is it y minus 2?
Y minus f of x.
Yeah, you got to put 2 into there. What's 2 squared? It's going to be what?
4 minus 4 plus 3 is 3.
Wait a minute. Hold on. Is that the right factorization? Is that the right factorization?
No.
No, it's not. It's not. So I am just on mission to destroy your understanding today, okay?
Yep.
What does it factor into?
Nothing beautiful. X.
Does it factor into anything nice?
No.
No, it doesn't.
Calculator.
We do have your calculator, but the point is, you have this, you have the point here. What's the point there? Well, we know when you plug in 2, what's x going to be? When x is 2, what's y? Sorry.
Negative 3.
No, it's
3.
3. It's 2, 3. So we know you have this tangent line. What is the equation of that tangent line? Y minus 3 equals, we know the slope is what? 2. We figured it out already, and then I erased it, even though that was okay. 2 times x minus what?
2.
X minus 2. Yep. So then we know that y is equal to what? 2x minus 4 plus 3. So it's 2x minus what? 2x minus 1. So that's the line right there.
Oh, wait, never mind.
It's minus 4 and then plus 3. So it's 2x minus 1. They want to know when the difference between that and the other one is less than 0.5, right? So they want to know when.
Fill 'em in, or what?
So then what do?
You
You literally just do the subtraction.
Minus 2x plus 3
Minus.
2x minus 1.
Minus 1 like this, right? So what do you get? X squared minus what? 4x plus what?
2. 4.
Plus 4, right?
Yeah, 4.
Plus 4, like this.
Yeah.
Is that a nice thing?
Yeah.
Yeah, that's x minus 2 what?
Or x minus 2.
X minus 2 squared, right?
Yeah, and we need to know when that's
Less than what? 0.5. We need to know when that is less than 0.5. So this is going to be x minus 2 squared less than 0.5 because it's always positive, right? So we square root both sides. We know that x minus 2 has to be less than what? We square both sides. It's equal to 1/4,
Yeah.
right? So then we root of 0.5. We're square rooting both sides.
Root 2 over 2.
It's root 2 over 2. So this right here is 1/2. So this should be 1 over root 2, which is
Root 2 over 2.
root 2 over 2. So x has to be less than 2 plus root 2 over 2. And they're just having you estimate right here, right? So you have to go back and look. What is root 2 approximately? You have your calculator, right?
Yes.
So x has to be less than what's 2 plus 1.414 over 2? What's that come out to be? What's that decimal, please?
2.7.
Someone give me the exact decimal right here.
E.
2.7 what?
0.710.
Yeah. So then you go up here, and what does it have to be? 2.7. The velocity at time t is going to be, and they give this is acceleration, right? It's going to be the velocity at 0 plus the integral from 0 to 6. It's 0 to 6. Oh, 0 to t. Yes. Yeah. 0 to t of v prime of t dt. But what is v prime? A. So you're going to get velocity at 0 plus the integral from 0 to t of a of t dt. So they're asking you to use the left-hand Riemann sums to estimate this right here. So what I do in my head is I just need to actually see a picture of this, right? So here's 0, 5. Here's 2, 2. Here's 4, 8. And here is 6, 3, okay? And here's the x-axis. So you're using the left hand. You're using the left hand. So you have these dividers here, the left hand of each of these. So you have that division from 0 to 6. You're using the left hand addition. So how would you do that if you're using the left hand ones? So what's the height of the first one?
5.
So you have 5 right there, and then it's there, and then it's, well, less of a trapezoid and more like this, right?
Yes.
So you just have to, the number one thing you have to be careful of is the width, because sometimes the width will be consistent, sometimes it will not. In this case, the width is 2 and then 2 and then 2. Is it always that way?
No.
No, we just did one on the AB from 1997. Was not the same, and it throws. They will give you that answer if you assume they're all the same. So in this case, it's 2 times 5, so it's 10. 2 times 2 is 4. 2 times 8 is 16. So you end up with what?
30.
Or this is jumping around here. What do you end up with? 30. So you end up with, and what's v of 0? It tells you it's 11, right?
11. So 11
Plus
30.
is equal to 41
47.
feet per second. Exactly. Is it there? Yes.
Yes.
Okay, so we got a Taylor series. Yay, exciting. If that's a Taylor series that converges to f of x for all x, then f prime of 1 is going to equal what? So you can actually do the derivative, can't you? Can't you just actually just do the derivative? What do you think? It's too many things out loud, okay? Look, I would like you to do this. If you were to take the derivative of this right here, if this right here was your f of x right here,
Oh.
right? That's your infinite sum. That's one element of your infinite summation,
Yeah,
right?
You get a sub n times
Yes.
minus 1.
So you end up with f prime of x is equal to the sum of what? N equals 0 to infinity of a sub n times x to the what? N minus 1. But is it asking you for that? No, it's asking for f prime of 1. So f prime of 1 is going to be what? When you plug 1 in, what happens?
You get
Plug 1 into this, literally what happens?
1 times 1.
Wait, an times time, well, x to the 0, right? So you end up with what? 0 to n of a sub n. Is that there?
Yeah.
Is it there?
Yeah. A sub 1.
Yeah. Yeah, like, this is not, this is an x value.
They're
So,
expecting you to make
yay.
that mistake.
They're expecting you to make that mistake. Literally, that's an n value, so what stays there? N. We're not plugging in for n. What are we plugging in for? Why did I change the lower limit? What do you mean? What lower limit? that's a good question. Why did it go suddenly? It changes it to 1 right there. We're not plugging in there. We're plugging in there, right?
Yeah, that's what's
So this should be 1 to the n, right? Which is just what? 1. Which is just 1.
Still, then how does it get
But then how does it change into 1?